My name is Vice President, a student from Presec Osu and a business student. My presentation is on photosynthesis. When you say photosynthesis, the process by which plants manufacture their own food in its organic matter, such as carbon dioxide, water, oxygen, chlorophyll. It can also be said as process by which water, carbon dioxide combine in the presence of sunlight and chlorophyll to form food substances such as glucose. And we have an equation that shows what I said. 6O2, that's the carbon dioxide, 6H2O, the water, and the process is sunlight, chlorophyll. It should give you C6H12O6 plus 602. So we have glucose and water. And you also see photosynthesis. As I've said earlier, plants manufacture their own food through the process of sunlight and chlorophyll to form food substances such as oxygen. Without sunlight, plants can manufacture their own food. For example, when you have a plant that is exposed to sunlight, let's say A, and another plant that is not exposed to sunlight, let's say it's in your room. When you are testing for starch, since this one is exposed to sunlight, you find the chlorophyll in it that will give you the starch. But to this one, when you are testing for starch, you don't get the starch. It will turn into orange or brown. Yes. And we also have some factors that affect the rate of photosynthesis. These factors are temperature, we have and also called enzymes, and also we have temperature, enzymes, and light intensity. To the temperature, as temperature increase, the rate of photosynthesis also increase, since more energy is supplied to the plant. And to the enzymes, let's move on to the light intensity. The light intensity can normally affect the rate of photosynthesis. This is because light is a limited factor in photosynthesis, which limited the shade of plants adorn and dash for other plants. Shade plants, for example, those in forest, have only short period of day. When light intensity is not limiting at those places, there will be a great competition between those plants. They can't manufacture their own food since there's no light. Also, we said assuming all other factors remaining constant, some amount of carbon dioxide and water, and people always ask which plants have a high rate of photosynthesis. Since one is exposed to light and the other is not exposed to sunlight, or let's say light, the first one being exposed to light, when you are testing for starch in it, you will find a starch because that's all the nutrients the sunlight that is exposing to it. But to the one that is not having the sunlight, or the one under your room or the window stage or your room temperature, it's not exposed to light or sunlight, so there will not be starch in that flower of that tree. Also, the higher the temperature, the greater the rate of photosynthesis. Let's talk about the enzymes. The enzymes are potent. They are protein molecules whose activity are greatly influenced by temperature. Work on enzymes showed that an increase of 10 degrees Celsius affecting double the activity of enzymes. The optimum temperature for photosynthesis in most tempered of a plant is 30 degrees Celsius. The rate is reduced at lower temperature. However, if the temperature rises above a clerical value of 40 degrees Celsius, the enzymes in the photosynthesis also will increase. Let's talk about also this question. They said the higher the temperature, the greater the rate of photosynthesis. In this statement, is this statement true, always true in circumstances? Give 5 reasons or reasons to it. No, because the enzymes are protein molecules whose activity are greatly influenced by temperature. Working enzymes are increased at 10 degrees Celsius, affecting double the activity of enzymes in the plant. We also move on to the investigation that need for carbon dioxide for photosynthesis. First step, we start the leaf of a plot. Example, cowpea. Second, you pluck a leaf from the plant and test it for starch. Enclose one leaf in a conical flask. You enclose one leaf in a conical flask labeled A, containing soda lime. This is a soda lime. And another leaf in another conical flask labeled B. Now the conical flask labeled B. And this one is A. Pass the leaf stack through a split cork which has been released to keep the flask airtight. What is the role of the soda lime in flask? Support each flask with a clamp. Place the plant in sunlight for about 3 hours. Remove the leaves from the flask and test each for starch. Also, investigating the necessity of light for photosynthesis. 1. Discharge the green leaf of a plant. Let's read the leaf. You cut a shape such as cross. So you place your leaf. You cut a shape such as cross, something like that. Place the plant in sunlight for about 3 hours. Remove the cover and test leaf for starch. You could see that the sunlight will only expose to this place or have an effect on this place, but to the other ones it's not going to have an effect because there is something covering the flower. So when you are testing for starch, the one being exposed to sunlight, that's what you get a starch, but the one not being exposed to sunlight will not give it a starch. That one will turn into different color. By here being exposed to starch, being exposed to sunlight, sorry, will give it the starch. Let's move on also to the investigating necessity of chlorophyll. When you say chlorophyll, they are the green pigments found in plants. To investigate the necessity of chlorophyll for photosynthesis, you need to discharge a plot plant with variegated leaves. Example, you take two leaves. Variegated leaves. Test leaf to check that it is discharged. If there is still starch, place the plant in dark for another 24 hours. Place the plant in sunlight for about 3 hours. Draw one variegated leaf to show the pattern of green and non-green grass. Test the leaf you have drawn for starch. What do you learn from this experiment? You can see that when a variegated leaf is tested for starch, the green plant containing chlorophyll turn blue-black in color, while the non-green plant lacking chlorophyll. Example, you have this tree. This one is exposing to sunlight, and the one in your room is not exposing to sunlight. You plug one leaf from each. From the one being exposed to sunlight and the one not being exposed to sunlight. Then you test each for starch. You could see that the one being exposed to sunlight is still having the chlorophyll in it. So when you test for starch, the color will turn to blue-black. Whilst the one not being exposed to the sunlight, its color will turn into orange or brown. So in this note, we have learned much about photosynthesis. You've seen how plants manufacture their own food by the help of sunlight. We support them, and also water in the roots that also help them to germinate and to also produce their own or manufacture their own food. We also saw the need of carbon dioxide and oxygen. Carbon dioxide and water, which give a byproduct as oxygen. O2, that's the oxygen, that's the byproduct of photosynthesis. And also it gives you glucose. So in conclusion, you could have seen that photosynthesis have done much for plants. It has helped plants to manufacture their own food with the help of sunlight, glucose, which is a byproduct, water, which also help plants to manufacture their own food, sunlight that is being exposed to plants, which help them to grow well, and oxygen, which the plant gives to us as a byproduct. So when we take in oxygen, we bring something out called carbon dioxide. Carbon dioxide. That helps the plant to grow. Thank you.